So our next round of trig fun is going to be taking a look at different sum and difference identities. And as we progress, you're going to see a whole bunch of formulas that are going to come up. Let me put your mind at ease. You don't have to have these memorized. I will provide these for you on a formula sheet. You just have to know how to use them and when to use them. So the reason we're taking a look at these in this first exploration is a lot of times we see something like that first notation, f of u plus v is equal to f of u plus f of v. And we think that that should always work. That doesn't always work. And two really big situations where that doesn't work is something like this first one, knowing that u plus v, that whole quantity squared, it doesn't equal this. This we have to actually expand on, right? So we'd have to do something like u plus v times u plus v. And when you do that, the thing that this is missing is that middle term. When we do the distribution and we see u times v and v times u, they're missing that 2uv in there. Okay, so that doesn't work. The same thing down here with these square roots. I can't split a square root up while I have a number underneath adding. If it was multiplication, cool, that would work. So for instance, if I had something like u times v, that's okay. This works. Square root of u times the square root of v, that's cool. But this additivity under the square root, no good. Okay, so we're going to take a look and see, does it work for trig or not? So first thing, we're going to let u equal pi and v equal pi over 2. And we're going to actually test these out. We're actually going to see, if I were to plug it into this first one, will it be the same thing if I did them separately? So the sine of pi plus pi over 2. All right, so if I added 1 pi plus a half a pi, that's really going to give me sine of 3 pi over 2. That's a quadrantal angle, right? And if I were to evaluate that, that's going to get me the value at -1. What if we did them separately? So sine of pi plus sine of pi over 2. So individually, we're going to evaluate. So sine of pi, again, these are all quadrantal angles, is 0. Sine of pi over 2 is 1. And that doesn't work. Okay, so I can't use that concept. Okay, we're going to test it for cosine. Okay, so same thing. So we're going to say, let's do cosine of 0 plus 2 pi. Okay, so 0 plus 2 pi, if I added that up, that's really like saying cosine of 2 pi. And to evaluate that, that's going to get me a value of 1. Okay, if we do them individually. So the cosine of 0 plus the cosine of 2 pi, again, all quadrantal angles here. So cosine of 0 and 2 pi, it's at the same location. They both have a value of 1. And if I add them, they get 2. So again, no, that's not working. Okay, so what about tangent? We're going to just make some values up to confirm this. And this would work for anything. Why don't we just say, we'll just keep it easy. I'm going to say let u equal pi over 3, and v is going to equal pi over 3. Okay, you could pick different numbers. You're going to get the same results no matter what you do. So if we do tangent of pi over 3 plus pi over 3, okay, so that gets you 2 pi over 3 when we add it. So that's in our second quadrant. And when you do our triangles, tangent in the second quadrant number is negative. That's going to get you square root of 3. Okay, so if I were to draw out a triangle to support the second quadrant, I would have this being our 2 pi over 3. So that's really like 120 degrees. So my reference angle is 60. So this is, square root of 3. This is my 1 and my 2, so that's where we're getting that tangent from, opposite over adjacent. Okay, if we take them separately, tangent of pi over 3 plus tangent of pi over 3, okay, so now we're dealing with a 60-degree angle in the first quadrant, so they should be positive. Here's your triangle. So tangent being opposite over adjacent, I can see they're both going to be square roots of 3. And when I add square root of 3 plus square root of 3, I get 2 square roots of 3, definitely not a negative square root of 3, so again, no bueno. Okay, so that basic idea of just saying, well, I'm going to take them and add them up, they're going to be the same thing as if I do it separately, that does not work. We could do the same exact thing for subtracting. Same process, you're going to see that they are not going to work. So that brings us to these formulas. Now we'll go through in class how they came up, how they're developed, how we could turn one into another, just so it's maybe not math and magic. But these are the formulas that we need to be aware of. And again, these are on your formula sheet. You just have to know how and when to use them. So the cosine of a sum or a difference. Okay, so a couple of things to note here. When we're doing the cosine formula, notice that if I'm adding the angles in the formula, I'm subtracting. Notice in the cosine, I have cosine A, cosine B, and then it switches sine A, sine B. Okay, so notice the sign change no matter what we're doing here. When you get down to sine, a couple of things happen. The signs don't change. Okay, so they are not switching. So if I'm adding 2 angles with sine, I'm adding 2 values in my formula. But do notice what does switch. All right, where cosine was both cosine and then I go to sine. Now when I have the sine of 2 angles, I have a sine and a cosine together. Sine and a cosine together. Okay, so we're going to apply this. And we're going to think, why do I need this? Who cares? Okay, well, I have no idea what sine of 15 is. 15 is not a reference angle. I can't find it. It's not a 30, a 60, a 45. It's not a multiple of. But I could say the sine of 15 is really like taking the sine of 45 minus 30. That would get me 15. And I have triangles that I know exist with angles of 45 and 30 that I could evaluate without a calculator. So if we were to use the formula that says in the sign I am subtracting, it looks like we're using this second idea here, where A is going to be 45 and B is going to be 30. So this would give me the sine of 45 times the cosine of 30. And now I need to subtract, keeping the signs the same. And now I switch to cosine of my first angle, which was 45, and the sine of 30. Okay, so we have to evaluate these. We give yourself some triangles, draw them out. So we got our 45, 1 square root of 2, and our 30. So we have 1 and 2 square roots of 3. Okay, so sine of 45, we get 1 over radical 2. Cosine of 30 would get us square root of 3 over 2. Now I'm going to subtract out the cosine of 45, so that's 1 over radical 2. And then I multiply that by the sine of 30, so that's 1/2. Okay, so we have to simplify. Multiplying fractions, tops with tops, bottoms with bottoms. So I get square root of 3 over 2 radical 2. And I subtract out 1 over 2 radical 2. Now, I'm subtracting fractions. They have a common denominator. We can combine this into 1, and we just get the quantity square root of 3 minus 1 over our common denominator, 2 radical 2. So this is your final answer. And we evaluated sine of 50 without a 15 without a calculator and not needing a fancy triangle. Okay, so what if I get something like pi over 12? First off, you could convert this to degrees. If that's a comfort, that's fine. It doesn't really matter if you do these in degrees or radians, and that gets you 15. You could also do this in radians. I'm going to try and take you through this just so you have an example. So this I could split up, and I could do cosine of 4 pi over 12 minus 3 pi over 12. So if I simplify that, that'll give me 1 pi over 12. Well, 4 pi over 12, if I were to reduce that, that's really like pi over 3. And 3 pi over 12, if I were to reduce that, that's pi over 4. Okay, so now we have our cosine. So I have to think cosines, they stay the same trig function, but I have to switch the signs. I'm going from subtraction to addition. Okay, so we have here cosine of pi over 3 times cosine of pi over 4. Now we switch our signs, and I go to sine. Sine of pi over 3 times the sine of pi over 4. Okay, so pi over 3, so that's our 60 degrees. So maybe let's get our reference angle over here. And we're going to have square roots of 3 and a 2. Sorry. I should also say in degrees, keep in mind pi over 3 is really 60. Pi over 4 is really 45. So if you did turn this into degrees and do it that way, completely cool, just so that you understand what we're doing. Okay, so pi over 3, cosine of pi over 3, that's going to get us 1/2. Cosine of pi over 4 is 1 over radical 2. And then sine of pi over 3, that is going to get us square root of 3 over 2. And sine of pi over 4 is 1 over radical 2. So again, since we're multiplying these, we can do tops with tops, bottoms with bottoms. So this will leave me with 1 over 2 radical 2. This will leave me with radical 3 over 2 radical 2. And now we can combine into one final answer, 1 plus radical 3 over 2 radical 2. Okay, so what if we go in the opposite direction? So if I have something that looks like this, it's saying, so what's the angle that we're actually trying to solve here? So I have to take a look at some patterns. I see a sine and cosine. So once I see that switch, that automatically makes me think I'm using the sine formula. And in our sine formula, if it is subtracting, that means I'm doing the same thing to begin with, to keep the same sign. So this problem here would really be like saying, evaluate the sine of 25. Okay. For this next one, I see cosine, cosine, so I'm seeing that they're both the same. And I'm seeing an addition, so I'm thinking, since they're both the same, I know I'm using my cosine formula. In my cosine formula, I want to switch the signs. So I have pi over 7 minus x. And for number 5, so again, checking out what we have, I have a sine and a cosine, so that automatically makes me think we're going to do sine. I know when I'm doing sine, the operation stays, so I'm adding within the formula, so I'm going to be taking my 2 angles and still adding them. And now we will simplify this, so they need a common denominator, which would be 10. So I would multiply my first fraction by 2 on the denominator, so that means my numerator is 2 pi. Multiply the second fraction by 5, so that means my numerator here is 5 pi. And if we simplify this, we're going to have the sine of 7 pi over 10. Okay. Now, we can also do some identities. These identities are kind of fun, kind of a little bit easier, because we have a formula to plug it into. And anytime you're doing identities, you're trying to make the left look like the right. So it's saying use this formula. Use that sine of the subtraction or the difference of 2 angles. So if I plug it in, we have sine of x, cosine of pi over 2. Sine stays the same, so minus. And now we have cosine of x, sine of pi over 2. And we can evaluate. Pi over 2, that's our quadrantal angle, right? So that's our 90-degree angle up here. The coordinate is 0, 1. Keep in mind it goes cosine comma sine. So we have sine of x times 0 minus cosine of x times 1. Okay, so anything times 0, that drops out. Cosine of x times 1 is cosine of x, and we're subtracting. So we're left with our negative cosine of x, and you've proved your identity. Okay, we'll try another. So we're dealing with cosine this time, so I want to think cosine formula. It always goes cosine, cosine. My sign switches. Okay, so we have cosine x, cosine of pi over 2, switch my sign to adding, and now I get sine of x, sine of pi over 2. Okay, so again, cosine of pi over 2, that's going to give me 0. So I have cosine times 0. And then sine of pi over 2, that's going to get me 1. So 0 times anything goes away, and I'm left with sine of x. And so lastly, it's our tangent formulas, our tangent adding and subtracting sum and difference. So we can always take a look at tangent as sine divided by cosine. So we could have our sine formulas divided by our cosine formulas. And notice how the formulas are written here. I have a plus on top and a minus on the bottom. So it's kind of a combination of the formulas. Meaning if I read the top of this formula, tangent of u plus v, that means I would be doing sine of, read the top, u plus v. Here's my formula. Read the top, take the top sign. Same thing down here, take the top sign. But if I were to do tangent of u minus v, then I need to do sine of u minus v. So it's like they've combined the formulas. So if I take the top symbol all the way across, or I take the bottom symbol all the way across. So I can always think of tangent as sine divided by cosine. That's an option. Sometimes I can't do that, especially if we have like quadrantal angles, because if I get a 0 in the denominator, sometimes, well, we can't have a 0 in the denominator. Then we can go to this tangent formula. And this is an actual, your actual formula for tangent using tangent properties. So you have two ways to calculate the sum and difference of tangents. And again, they will be, this I should say, will be provided for you. Keep in mind, if you got something that was undefined, then you may need to go back and use the sine divided by cosine. Okay, so we have tangent of 5 pi over 12. Again, this is something that you could convert into degrees if that's more comfortable for you. This is representing 75 degrees. So I'm thinking to myself, if that's 75 degrees, I could do something like 60 plus 15. That's an option. If I did this in radians, just so we can see how this works, this would be like saying tangent of 2 pi over 12 plus 3 pi over 12, which when we reduce this, that gets me pi over 6 plus pi over 4. And remember what we said, I could do 60 plus 15. That's really what that is. Okay, so using our formula, and I'm adding, so that means if I were to look at the formula that they gave us, I want to read my symbols for adding, so that would be my top one, meaning I need my top signs on both. Okay, so I have tangent of pi over 6 plus pi over 4. That will equal, so I'm reading my top signs, tangent of pi over 6 plus tangent of pi over 4, and now we have to divide that by 1 top sign minus tangent of pi over 6 times tangent of pi over 4. Okay. Pi over 6, that's our 30-degree triangle. And pi over 4, that's our 45-degree. Okay, so tangent of pi over 6, that's going to get us 1 over radical 3, plus tangent of pi over 4, that's 1. And divide that by 1 minus 1 over radical 3 times 1. Okay, so we have to simplify. We need common denominators. So this 1, I could really write this as square root of 3 over square root of 3. Okay, so if I did that, now my numerator combining this is going to look like 1 plus radical 3 over radical 3. Same thing here. So I know that this first part is going to be 1 over radical 3. I need a common denominator, so I'm thinking square root of 3 over square root of 3. And then combine. So I have radical 3 minus 1 over radical 3. Okay, so we're going to copy, change, flip. So copy, change, flip. And notice that our square roots of 3 drop. So our final answer we have here is 1 plus radical 3 over radical 3 minus. Okay. And then lastly, like we did before, we can kind of work this formula backwards and say, okay, what do we have? So I see my two angles. I know it's going to be tangent. I know it's going to be 19. I know it's going to be 47. And I just have to identify, am I adding or subtracting? Since I have a plus sign here and a minus sign here in my formula, those were both on the top, which means I'm adding these. So this is a way of saying the tangent of 66. Okay, we'll practice a little bit more in class and see where these formulas came from. Hope you guys have a great day.